All right, let's go through chapter 17. Chapter 17 starts our next section of the course, which is on something called confidence intervals. And we'll also talk about something called hypothesis testing in chapters 18 and 19. But today we're going to focus on what a confidence interval is. Confidence intervals you may have actually heard of unknowingly before. If you've ever heard the term a margin of error, um, especially when they talk about political polls, they'll say, oh, so and so is polling within the margin of error. That actually has to do with a confidence interval. So we're going to talk about what that is today in chapter 17. So a confidence interval is a way of estimating a true proportion or mean for large populations. So what does that mean? Very often, and we talked about this in chapters 10, 11, and 12, when we're sampling, very often it's logistically impossible to sample the entire population. If you think about political polls, it is logistically impossible to poll every single eligible voter. So what they will do is they will sample just a small portion of the of eligible voters and then use that data to make predictions. And that's really what a confidence interval is. To use the voting example. We sample a certain proportion, a certain percentage of the population, and then we can use that to try to interpret or figure out who's going to get the most votes in the actual election. Okay, and this is how we interpret a confidence interval. Depending on what percentage confidence interval you are finding, the most common one is a 95% confidence interval, but there are others. Basically, what a confidence interval tells you, it tells you that you're whatever percent confident that the actual proportion or the actual percentage is within that interval. So if you find, for example, a 95% confidence interval for voting, then you could be 95% sure that the actual percentage of votes that a candidate is going to get is within that interval. And we're actually going to do an example like that in a little bit. In order to find a confidence interval, there are four conditions that have to be met in order for the confidence interval to be valid. And we're going to go through all those quickly. For the purposes of this class, you can assume that all those conditions or those characteristics are met. But in the real world, if you were going to do a confidence interval, you would have to make sure that those conditions were met. So the first one is kind of obvious. It's the randomization. It's known as the randomization condition. We talked about in the past why it's important for a sample to be truly random. We don't want the results to be biased. So the samples have to be truly random. Whatever sampling method you use has to include steps to ensure that it's random. Okay. Next one is called the success failure condition. Um, so the sample size must be big enough to expect at least 10 successes and 10 failures. What does that mean? That means if we were doing a confidence interval for voting for candidates, we would need to make sure that the sample size is big enough so that we had at least 10 people voting for one candidate and 10 people voting for another candidate. That's all that means. And that's called the success failure condition. The third characteristic or condition is called the independence assumption. Very often, um, confidence intervals can involve multiple samples, multiple values. And what the independence assumption says, as it says here, is that the sample values must be independent of each other. So what that means is that you need, when you take your samples, all of the data points need to be independent, meaning that one result can't affect future results. We've talked about what independence means in the past, and it means the same thing here. The last one is kind of confusing. It's called the 10% condition. If sampling is without replacement, and we've talked about what without replacement means, if sampling is without replacement, the sample size must be no more than 10% of the entire population. So to use the voting example, if we were going to do take data, do a poll, and make a confidence interval, that the number of people that participated in that poll have to be no more than 10% of all eligible voters. Now, I know that may seem confusing to some of you, because we always talked about it. It's better to have a bigger sample size than a small sample size, and that is true. What I am going to say is there actually is a mathematical proof that shows why the 10% is the threshold here. I'm not going to go through that for the purposes of this class. That the reasoning and the proof behind that is kind of beyond what I would expect you to be able to do in this stats class. If you were to take a higher level stats class in college, you may go through that proof, but just know that there is sound mathematical reasoning why the sample size can't be more than 10% of the entire population. So again, these four conditions here have to be met. They all four have to be met in order for a confidence interval to be valid. Like I said earlier, the examples that we're going to do in this class, okay, are you can assume that all four of those conditions are met for the purposes of this class. So how do we find a confidence interval? Just like with much of the stuff we're doing in this class, we are going to use StatCrunch. I'm not really interested in can you do all the long steps by hand. That is not important to me. As I've said before, what's more important to me is that not so much that you can find the answer, that you can interpret what the answer means. So we're going to use StatCrunch. So the way we find a confidence interval for a proportion or a percentage is these steps here. Stat, proportion, stats, one sample with summary. Okay. That's what it looks like. That's a screenshot of what it looks like. Stat, proportion, stats, one sample, and then we would choose with summary. And this is what it looks like. Okay. So you would put in your data, you would choose confidence interval, and then depending on whether it's a 95% confidence interval, you would put that in, and it would give you the answer. All right, so the number of observations is your sample size, and the number of successes, well, that would be like the number of people voting for a particular candidate. Okay, so to give you an example of how it works, I actually went ahead and looked up some data from the 2016 presidential election in Iowa, and this is actual data from a poll from the Des Moines Register. For those of you that don't know, the Des Moines Register is a newspaper, obviously based out of Des Moines. And this was the last poll they conducted prior to Election Day 2016. And this was the result of their poll. So they sampled 800 eligible voters in Iowa. Okay. And this was the result of that poll. So they had in that poll, they had 368 people said they were going to vote for Trump, 312 people said they were going to vote for Clinton, and 120 people said they were going to vote third party. Now, in the actual data, they actually listed out every single third party candidate. For the purposes of this example, I just took all candidates who were not Trump or Clinton, and I just lumped them all together under third party. And what we're going to do is we're going to use StatCrunch, and we're going to make what we call a 95% confidence interval for the proportion or percentage of votes for third-party candidates. And we're going to see what happens when we do that. So again, in StatCrunch, we go stat, proportion stats, one sample with summary. And so this is what I did. So when I did that, notice the number of observations, that's the sample size. That was the number of people polled. So there were 800 people, and out of those 800 people, 120 of them said that they would vote third party. And then I went here and notice it said 95% confidence interval. So under level, I put in 0.95 for 95%. And when I clicked compute, this is what came up. Now, what you want to do is you want to, when this comes up, all you want to look at are the last two. The last two, the L limit stands for lower limit and U limit stands for upper limit. The two of them put together make up the interval. So if you look at the lower limit, I rounded that to 0.13, and upper limit, I rounded that to 0.17. Okay, so my 95% confidence interval is between 13 and 17%. Okay, so what this confidence interval means is that at the time that this poll was conducted, and again, this was couple days very close to election day in 2016. At the time that this poll was conducted, we would be 95% confident that third-party candidates would actually receive between 13% and 17% of the votes in Iowa. So we would be 95% confident that the actual percentage of votes that third-party candidates would get would be between 13 and 17% within that interval. Okay. Now, I don't actually know what ended up happening, but that's what a confidence interval actually means. Okay. Here's another example. This was an example that I took from the textbook. We're constructing a 90% confidence interval for the proportion of all people who smoke cigarettes. So this was the data. They surveyed 1,815 people. Out of those people, 417 said that yes, they smoked cigarettes. So again, we went to stat, proportion stats, one sample with summary. So notice I put that data in. 417 out of 1,815 people said that they smoked cigarettes, and notice I changed that level to 0.9 or 0.90 for 90%. And I hit compute, and this is what came up. All right. So my confidence interval is, I rounded the lower limit to 0.21, and I rounded the upper limit to 0.25. Okay. So my confidence interval is between 21 and 25%. So what it means is that we're 90% confident that the actual percentage of people who smoke is between 21 and 25%. Okay. Now, some of you may be asking, why 90%, 90? Why don't we just say 100%? That's a very good question, and the answer is, and I've mentioned this in class before, we can never truly be 100% sure. Okay, we can take all the samples we want, but the bottom line is we can never be 100% sure, which is why we go with a different lower percentages than 100%. Okay. So that is the PowerPoint for this chapter. Now, what I'm going to do is I'm going to go, like I've done in the past section, in the past few sections since we went to online, I have one assignment for chapters 17, 18, and 19. And I'm going to go through just the ones out of the 10 questions. It looks like the first 4 questions in this in the chapter 17 through 19 assignment, the first 4 are actually based on chapter 17. So I'm going to go through questions 1 through 4. And then you should be able to do those questions after I go through this. Okay. So let's look at this. Okay. A catalog sales company promises to deliver orders placed on the internet within 3 days. Follow-up calls to a few randomly selected customers show that a 95% confidence interval for the proportion of all orders that arrive on time is 86% plus and minus 2%. By the way, that 2% right here, okay, that 2% is called the margin of error. Okay, in case you were wondering. So 86 plus and minus 2. So 86 plus 2 would be 88, and 86 minus 2 would be 84. So my confidence interval is between 84 and 88%. So this is basically asking, what does that mean? 84 to 88%. If we go back to the PowerPoint here, okay, that's our interpretation. So in this case, they did a 95% confidence interval. So we are 95% confident that the actual percentage is within that interval. In this context, that would mean that we're 95% confident that the actual percentage of orders that arrive on time is between 84 and 88%. Now, which one of these choices is closest to that? Okay. 95% of customers report no. One can be 95% confident that 86% of no. Look at C. One can be 95% confident that between 84 and 88% of internet orders will arrive on time. That's exactly what I was saying. So the answer to this one is C. Okay. Number 2. A student is considering publishing a new magazine aimed directly at owners of Japanese automobiles. He wants to estimate the fraction of cars in the U.S. that are made in Japan. The computer output to the right summarizes the results of a random sample of 50 autos. Explain carefully what it tells you. So it looks like there's a 90% confidence interval, and my confidence interval goes between 33 and 52%, 0.33, 0.52. So what this means, once again, is that we're 90% confident, okay? We're 90% confident that the actual percentage is between 33 and 52%. In this case, we're estimating the fraction of cars in the U.S. that are made in Japan. So what this means is we're 90% confident that between 33 and 52% of U.S. cars are made in Japan. All right, and which one comes closest to that? It's A. Okay. Number 3, and let's see, an agricultural researcher hoping to increase egg production gives a food supplement to a test group of 277 hens and find that they now produce 228 eggs a day. Construct a 90% confidence interval. Okay, so this one we're going to do on StatCrunch. So if you forgot from before, we go stat, proportion stats, one sample with summary. And I'll do that one more time. Stat, proportion stats, one sample with summary. So our sample size is 277 hens. So that's your number of observations. And the other number is, let's see, 228. Okay. And we're going to go down here. And let's see, it was a 90% confidence interval, I believe. Yes. So we're going to change that to 0.9 for 90%. And we're going to compute. And there's our answer right here. Let's make this a little bigger. Okay. Now be careful here. Notice they want the answer as a decimal. There's no percentage sign here. It says to round to 3 decimal places. So my lower limit is going to be 0.785. Oops. 0.785. And my upper limit is going to be 0.861, it looks like. Okay, and that should be our answer. There we go. Okay. Last one for chapter 17 is number 4. Okay. Philanthropic organizations sent free mailing labels and greeting cards to a random sample of 100,000 potential donors on their mailing list and received 4,635 donations. And we're looking for a 99% confidence interval. By the way, notice in this case, notice they want the answer as a percent. So when it says round to 2 decimal places, what that means is convert it to a percent first and then round to 2 decimal places. All right, so we'll talk about that after we actually go through the process here. So we're going to go to StatCrunch and we're going to go stat, proportion stats, one sample with summary. All right, 100,000, that's going to be our sample size. So 100,000. And then the number of success is going to be 4,635. Okay. And we are looking for this time a 99% confidence interval. So we're going to change that to 0.99 for 99%. And let's compute it. Okay. So again, when we do this, we're going to convert it to a percent first and then round it to 2 decimal places. So in this case, it's going to be, let's remove that, 4.46%. Okay, move that 2 spaces to the right and then round it to 2. This one's going to be 1, 2. This is going to be 4.81%. So the 99% confidence interval is from 4.46% to 4.81%. All right. And that should be the correct answer. It is. Okay. So that is it for chapter 17. I will be back with another video for chapter 18 and a video for chapter 19 as well.